If you were standing near a black hole in space, you would hear nothing. Space is almost a perfect vacuum, and sound cannot travel through empty space. On Earth, sound moves through air as vibrations between molecules. This chain of motion carries sound to our ears. But in space, there are almost no particles to carry those vibrations. Without a medium, sound waves simply cannot propagate. This is why space is often described as completely silent. Yet the universe is not truly without motion. Enormous cosmic structures are constantly vibrating and shifting. Gas clouds ripple as energy moves through them. Galaxy clusters contain vast oceans of extremely hot plasma. In these dense environments, pressure waves can travel. A supermassive black hole can disturb this gas dramatically. Jets and energetic eruptions push through the surrounding plasma. These disturbances create enormous ripples in the hot gas. In a sense, these ripples behave like sound waves. But their frequencies are far below the range of human hearing. To study them, scientists convert these cosmic vibrations into audio. This process allows us to experience the hidden rhythms of the universe. To understand the sound of a black hole, scientists study the environments around them. One of the most famous examples comes from the Perseus galaxy cluster. This enormous cluster contains vast amounts of extremely hot gas. At its center lies a powerful supermassive black hole. Activity from this black hole disturbs the surrounding plasma. As energy erupts outward, it creates expanding pressure waves. These waves move through the hot gas, filling the galaxy cluster. In many ways, they behave like sound waves traveling through air. But the scale is far beyond anything on Earth. Some ripples extend across tens of thousands of light years. Space telescopes detect these waves using X-ray observations. Variations in brightness reveal the motion of the gas. Scientists map these patterns to study the structure of the cluster. The waves move incredibly slowly compared with familiar sounds. Their frequencies are far below the range humans can hear. To make them audible, researchers shift the frequencies upward. This technique is called sonification. Data from space is translated into sound we can perceive. The result is the haunting tone, often called the sound of a black hole. What we hear is not sound in space, but data transformed into human experience. Deep inside the Perseus galaxy cluster, scientists discovered enormous ripples in the hot gas. These ripples behave like pressure waves moving through the plasma. In many ways, they are similar to sound waves traveling through air. But the scale of these waves is almost unimaginable. Each ripple can span tens of thousands of light years. The waves move through gas that is millions of degrees hot. Astronomers detected them using sensitive X-ray observations. Subtle variations in brightness revealed the motion of the gas. When mapped carefully, these patterns formed enormous circular ripples. At the center of this activity lies a supermassive black hole. Powerful outbursts from the black hole push energy into the cluster gas. That energy travels outward as pressure waves. Scientists measured the frequency of these cosmic vibrations. The result revealed something extraordinary. The waves correspond to the lowest note ever detected in the universe. Its pitch is far below the range of human hearing. In fact, the note is many octaves below what our ears can detect. To study it, researchers shift the frequency upward dramatically. This transformation allows the cosmic signal to become audible. What we hear is a translated echo of enormous waves moving through a galaxy cluster. The sound of a black hole does not travel through empty space. Instead, it is discovered through careful scientific observation. Astronomers measure waves moving through hot cosmic gas. These pressure waves behave similarly to sound in a dense medium. But their frequencies are far too low for human ears to detect. To study them, scientists convert the data into audible frequencies. This process is known as sonification. Sonification transforms measurements into sound we can perceive. The original waves may take millions of years to complete a cycle. Their pitch is incredibly deep and slow. In the Perseus cluster, this vibration forms the lowest note ever detected. The note lies dozens of octaves below human hearing. Researchers shift the signal upward to make it audible. What we hear is therefore a scientific translation. It is not sound traveling through the vacuum of space. Instead, It is data revealing hidden motion in the universe. These vibrations help scientists understand black hole energy. They reveal how black holes influence entire galaxy clusters. Through data and technology, the silent universe becomes audible. In this way, the real sound of a black hole is the rhythm of cosmic physics.